All right. Hello, everyone. Welcome to the International Methods Colloquium. I'm Justin Essery, Associate Professor of Politics and International Affairs here at Wake Forest University. The IMC is a periodic online interactive seminar discussion on the application of quantitative statistical methodology to the social sciences, sponsored by Wake Forest University and previously sponsored by Rice University and the National Science Foundation. The IMC is affiliated with the Society for Political Methodology, who hopes that you will support quantitative research in political science by joining. The membership fee is just $10 a year for graduate students. I will post a link to join the society in the Zoom webinar chat window after this introduction. This week's speaker is Tara Slough, an assistant professor in NYU starting next year in 2020. Her talk is entitled On Theory and Identification, When and Why We Need Theory for Causal Identification. Tara's talk will last between 30 to 40 minutes, after which point we'll take questions from the audience. You can ask a question using the Zoom Q&A button that appears at the bottom of the webinar window. And you may ask questions at any time during the talk, but all questions except for clarifying questions will be held until the end of the presentation. If there is a clarifying question, I can break in to ask it. Link to Tara's paper and slideshow will be available in the Zoom webinar chat window so that you may refer to it throughout the presentation, and I'll post those links right after this introduction. And now I'd like to welcome Tara Slough to the IMC. Tara, welcome.
Great. Thanks all for joining, and thank you so much, Justin, for organizing this. It's a pleasure to be doing this. I am an applied empirical researcher, and one thing that strikes me when we are looking for research designs capable of identifying causal effects is that we put a lot of effort or expense into the right-hand side of an estimating equation, so to speak. And so we can think about this in terms of field experiments, which often quite literally cost a lot of money. They require big grants for implementation and measurement in order to randomize these treatments in the world. But I mean, also, we can think about identifying new types of natural experiments requiring a lot of effort and expertise. And so there's an idea that's been sort of transmitted to me as a grad student with sort of limited research funds that in many cases collecting a lot of outcomes is comparatively cheaper. So there's advocacy for doing ancillary or downstream experiments collecting new outcomes where someone has already done randomization or identified some type of exogenous variation in the world in the treatment. And similarly, while doing a survey is expensive, the marginal cost of adding another question is relatively low. And so within this sort of research model, there seems to be an implicit assumption that given some as if random variation in treatment assignment, some causal effects and some causal estimate is identified for any downstream outcome. And we have an emerging set of questions about inference and sort of false discoveries when we're using different types of experiments or natural experiments. But sort of one thing that's sort of consistent is that, there should be some sort of like intent to treat type effect that's identified. This paper is going to show that this assumption does not necessarily hold. And I want to advance an argument that causal estimates are going to be identified by a design plus a theory. And so thinking about what this looks like, so often we can think of identification-oriented research design as having sort of treatment assignment. There may be non-compliance. Treatment may be somewhat different from treatment assignment. And then we can think about measuring Ys or multiple outcomes. And often when we estimate the effects on multiple Ys outside of, say, mediation analysis, we're not very explicit about what the relationship is between the multiple Ys. So we could think about two different causal graphs. Here, there's sort of no dependence or causal relationship between the Ys. Treatment causes, has an effect on Y1 and Y2, but there's no relationship between Y1 and Y2. On the other hand, here, Y2 is caused by, there's sort of a direct effect of treatment and also an possible indirect effect through Y1. And so I want to argue that the relationship between the Ys, so the differences between here and here, are going to matter really critically for identification. And I think that interpretation idea is more standard, but I want to maintain that. And so the argument I will put forward is that theory is going to provide the assumptions that discipline what quantities or estimates we should be estimating and guiding interpretation. And theory is the thing that's going to sort of tell us about the relationship between the Y's. Okay. So when I say theory in this talk, I'm referring to a model or some abstract representation of the world relying on deductive reasoning. So I like the analog between a theory and a map put forward by Clark and Primo and others. And ideally, theory should capture relationships between treatment assignment or treatment and then the Y's, but also what that relationship between the Y's looks like. For my purposes, the type of model that we're using is not important. The examples I'll go through are game or decision theoretic. One thing that's important for the talk is that we can formalize both the theory and sort of the research design so we can look at sort of the mapping between the two of them in a common language, so to speak. Okay. I'm going to scope the argument today to research designs that have possibly sequential outcomes, so outcomes in which some action is taken before another. And so this sort of puts us in the realm of dynamic models, which I think many research designs that we look at in political science fall within this category. So this is sort of a wide class of designs. And then I also am going to sort of scope the talk to causal estimands as sort of, in a best case scenario, reduced form tests of a theory. So we're going to look at the direction, but sort of two things. The estimands that we're estimating, so your ATT or ATE, is typically not a parameter of the model. And that we're going to rely on sort of inferences about the direction of effects. I think this is important. So, I mean, you could take this argument as a justification to do more structural work, which I think is fair, but I think it's important to address this within this reduced form world, which is the vast majority of common practice at the present in political science. There's sort of three literatures that I think this relates to. So, I mean, in sort of thinking about what the role is for theory within sort of identification-driven research, this talks to a debate on sort of whether theory and identification are in competition, what should be the prioritization, and are the two aiming at the same goals. I see this work as sort of the empirical work within the theoretical implications of empirical models, which is an emerging movement, sort of thinking about what we learn from different causal estimands about models of the world and what models can tell us about what we're actually estimating. And then this is going to be within sort of the identify sort of a post-treatment type of selection, which joins also emerging and growing larger by the day literature on the maladies of how we can mess up research designs with what we do post-treatment. So we can think about adding post-treatment controls, conditioning on sort of a manipulation check or conditioning the sample on something post-treatment, and then sort of selection and audit experiments is sort of one case of the problem that I'll talk about. So what I want to do in this talk is I want to just give an overview of post-treatment selection and why I think it poses issues for inference or for identification. I want to go through a stylized illustration from a police experiment in Colombia, the country. And then I will look at some more general results about when we need theory for identification. And then ultimately, I think this paper provides a number of recommendations for empirical research design. Okay. So the problem that I want to think about and how it sort of maps into the social science literature has been described at length in sort of biostatistics, medical, and other literatures, including some literature within policy or social sciences. And so this is sort of the phenomenon is often called truncation by death. And you can think about this as we have a clinical trial in which we're going to randomize some treatment, which I'll call Z, on a deadly disease. So a disease for which people have a substantial chance of dying in the near future. And the ultimate outcome of interest is some type of measure of quality of life or quality adjusted life years. But the problem that emerges is that some patients die during the trial. So we have sort of a first outcome, which is survival, and that comes before our ultimate outcome of interest. So one way this problem can be represented is via principal stratification. And so what we have here, we have four principal strata. So we have sort of a population of always survivors, so people who would survive whether they were assigned to treatment or control, right? So this is our survival outcome. So they survive both in treatment and control. An if treated survivor, that's somebody who survives in treatment but not in control. If untreated, they survive in control but not treated, and a never survivor doesn't survive at all. And so our ultimate outcome of interest are these Ys. So we could think about the Y bars as the mean within each cell. And so we can measure that for anyone who survives. So the always survivors in either treatment condition, or the if treated survivors here, or the if untreated survivors here. But quality of life is undefined, so in red, for people who don't survive. We don't know what sort of a measure of quality of life means for someone who is deceased. So what this implies, so we can write these as undefined. And what this implies then is that we can think about two different average treatment effects or intent to treat effects if you are concerned about noncompliance. So we can easily estimate an average treatment effect on survival, right? And so that's ultimately going to boil down. So if these are the shares that sum up to 1, to the proportion of if treated survivors minus the proportion if untreated survivors, okay? But then what we would need to do is we would need some weighted average weighted by the share in each stratum in order to look at the average treatment effect on Y. And the problem is because these potential outcomes are undefined, the average, when we evaluate that weighted average, that's also going to be undefined. And so sort of the argument in this literature is that there's issues at sort of shooting at an estimand that is undefined by trying to estimate it. And then there's inferential challenges because we can think about this being survival being endogenous to treatment. Okay. And so this, I think, is really critical to think that this is different from missing data or attrition. It's not just that I lost track of some of my clinical trial participants who ran away and I couldn't measure quality of life. Missing data would imply that Y of Z is just defined or not recorded. And one of the ways that we can distinguish this, so this is sort of like qualitatively separate outcome, is that the methods that we do have to address missing data are not going to define a potential outcome. So if we just impute some value, in some sense, we're losing information because we know this person died, and we're sort of and we're losing that information if we impute some type of quality adjusted or quality of life measure. Similarly, if you think about like a resampling approach where you resample from people for whom you who are missing, right? It's impossible to sort of resample this among the deceased. Okay, and so the critical feature of this problem that I want to think about what it looks like in social science is that outcomes are sequential. Okay, and that's not necessarily a necessary condition for missing data. So the outcomes are sequential. So basically, death, we have sort of survival or not before our quality of life measure is evaluated. Okay. And so the usual approach in this literature is to sort of change the estimand, so change what we're trying to estimate. And so a lot of this literature would suggest that you want to estimate an always treatment effect among the always survivors, which is often called like a survival average causal effect. And so that is basically going back to this map, looking at this treatment effect, okay, on quality of life. But the challenge here is that who is in this always survivor stratum is unknowable for the data because we only observe one potential outcome. So there's different approaches to doing this that I don't want to dwell on. So you could do interval identification via a bounding exercise. And then you could also think about model-based approaches to point identification or sort of taking sort of the difference on average between treatment and control and doing some type of sensitivity analysis. I want to just take note of what the estimand is, and we can talk more in Q&A about estimating this, but this is not the focus of the presentation. Okay. So in terms of the study of behavior, so when we're moving from this very like medical idea into the social sciences, when we study behavior, we often want to study actions taken by some actor, right? And the idea here is that we have a lot of reasons to believe that past actions or past things in a sequence can constrain the set of strategies available. And so if we're looking at what strategy an actor selects, then we need to think about sort of what were the strategies available. And one thing that is common when you read sort of theoretical models is that in some sense, what's happened in the past changes the strategies available. So we could think of, if you read the sequence of like a model, there's, if something happens, then the game ends and utilities are realized, else we go on, right? And so I'm really thinking about these if statements. And so to the extent that we have those type of statements, the sequence of your treatment assignment relative to sort of the past actions that are conditioning what strategies are available is going to become really critical for interpreting and for even identifying sort of the effect of a treatment on behavior, okay? And so the way that I think about truncation by death in sort of a social science context is that there's a non-availability of some strategy that we're like trying to measure at a history. And I'll look at that sort of by example and then more generally. And so we can think about a couple of different sort of some behavior as a vote for an incumbent, where we define incumbent as the candidate, not the party. And there's some type of selection. The incumbent doesn't run for whatever reason, right? And so if I want to know what is sort of just a direct sort of behavioral measure of a, does a voter vote for the incumbent or the challenger, right? If there's no incumbent to vote for, that sort of choice is in some sense undefined. We can also think in sort of a much more literal analog to the truncation by death literature. So there's a lot of work on behavior after conflict. And so if we believe that sort of the assumptions underlying a natural experiment that expose some communities to conflict and others not to, conflict has emerged, we could have differential survival or people there. And so if we want to identify the effect on some type of behavioral outcome afterwards, this becomes challenging for reasons that are sort of much more clearly linked to the death example. Okay. I want to talk through this logic with reference to a policing experiment. And so the experiment is in full disclosure, sort of an alternative treatment arm of one of the Medicaid 4 policing experiments. This one is in Colombia. And this is a see something, say something type campaign. So a campaign providing information and trying to get people to report crimes or malfeasance at higher rates. And so this is a treatment that's going to be cluster randomized at the police beat level. And so the way that this is set up as a model is not going to imply any SUTVA violations, even in the presence of sort of equilibrium effects. Okay. And so the mechanism that I think could be working is that this campaign is lowering the net costs of reporting. So it provides information, phone numbers about how to report to sort of local police precincts. And sort of numbers to call, but I think also it's working to try to counter social norms against reporting, which are pretty critical in this context. And so in terms of administrative outcomes, which I'm going to limit the discussion for at least until the Q&A, we have sort of administrative behavioral data on reporting to the 911 equivalent, which is 123. Across the city, this is about 15,000 calls a day. And then we also have, there's also crime incidence data, but this comes from police records. So what I want to do is I want a model of how this is changing behavior and then how this maps into the sort of behavioral outcomes that I'm measuring. And so this is a very simple toy model that's simplified even from the paper. And the idea is just to illustrate how changing what I believe is happening theoretically is going to change what sort of what estimands are identified and what I can learn from different empirical comparisons. So we can think about 3 actors. We have a suspect or somebody who could be committing a crime. We have a bystander who will observe the crime. And then in the paper, there's a police officer who's going to be non-strategic just for the purposes of time in this presentation. So the suspect is going to choose first whether or not to commit a crime. We could think of stealing something, whatever. The crime yields some benefit, lambda greater than 0, which is modeled as random variable and with a known distribution, and the CDF will note as f of lambda. And then if investigated, so if investigated by the police long term, the suspect's going to pay some penalty greater than 0. Okay. Critically, I'm going to focus on this idea about if a crime occurs, the bystander is going to see the crime and choose whether to report or not. Each bystander has some type of taste for order or justice, psi here, which is drawn from a common distribution. Most importantly with the CDF, f of psi here. And so reporting is going to incur a cost. And if you remember, the assumption is that the treatment is going to lower the net costs of reporting. And so we'll have the cost here is going to be lower in treatment than in control. Okay, and we'll index treatment and control by this superscript Z. Okay. So for the presentation, the officer is non-strategic. All you need to know is that they investigate crimes with some known probability, and if a crime is reported, it's more likely to be investigated than if it's not reported. So if we just draw the extensive form, so first we're going to have a suspect that makes the decision to victimize or not, so to commit the crime or not. And then we have the bystander, and given that the crimes occurred, they're going to choose whether to report or not to report. And this is ultimately what my reporting outcome is going to be a measure of. Did they report or not? And then we have the officer, who is going to be nature for the purposes of the talk, and they're going to investigate or not investigate. And sort of what I ultimately see as administrative crime records are measures of sort of what officers have seen. And so this recording outcome is going to come at the very end here. Okay, we have the utilities here. It's quite simple. There's two assumptions here that I think are really important for how we think about what we're learning from this theory. And first is that true crime incidents, so this thing that happens here, is going to be unmeasured. And this is sort of a general feature of a lot of studies of crime, right? We see what's been brought to the attention of authorities who are going to report it. We don't often see every crime that's occurred. And then the other critical assumption is that there's no false reporting, okay? So the bystander doesn't face this choice when there's no crime. Okay. All right. And so what I want to think about, what we can do with this theory, so this is super simple and highly stylized, is I want to characterize a couple different variants of the model. So basically what I've shown you is the full model, and we'll sort of add pieces to it as we go. And so what I want to do is I want to characterize either the optimal behavior of the bystander or the subgame perfect Nash equilibrium. And then from that, we can calculate these sort of empirical quantities. So the ATE of Z on recording, the survivor average causal effect of Z on reporting, where the survivor stratum is defined as beats where crime would occur in treatment or control, so regardless of treatment assignment status. And then what I want to think about is what is the quantity estimated by the treatment control comparison? So we can just think of like what comes out of a difference in means estimator. So I want to think first about a case that's like scoped back. And so this is a case where there is always crime to report, right? There's no variation across beats in people reporting crime. So what's going to happen is the bystander is always going to see crime, and they're going to decide whether to report it or not. And so via backward induction, we can think that if the bystander's taste for order is above a certain threshold, then they will report it. Right? And if you recall that psi, it comes from this CDF. And so the idea is the share that we'll report is going to be 1 minus the CDF evaluated at this quantity, right? And so then if the average treatment effect is the difference between treatment and control, we can evaluate that difference. And what we see is it simplifies to this expression. So F of psi with the cost of reporting untreated, and this should be Z equals 1, I apologize. And so this is going to be greater than 0 because if you remember, the cost is higher here. So this should say z equals 1. V is always going to occur. So where there's always crime, and so the ATE is going to be equal to the survivor average causal effect. And when I look at what the difference in means estimator estimates, it's going to estimate the average treatment effect, which is also the survivor average causal effect, and all looks good. Now, let's think about what happens when crime is exogenous. So crime is going to occur with some probability rho, and with probability 1 minus rho, it does not occur, okay? But when I think about the effect on reporting, which occurs here, right? The ATE here is going to be undefined due to selection into or out of crime, okay? So there's no branch here, there's no reporting that happens here by assumption. And then in the previous case, we're going to be focusing on the effect that happens at this history. And sort of logically, this is going to be exactly the same. We have the same typo here, but this is going to be the same effect that we estimated before because we're conditioning on crime occurring. But it's important to note here that then the difference in means estimator, because we're going to have the weighted average weighted by rho, what happens here, and we observe no reports here, but because the bystander didn't have the choice to do so. The difference in mean estimator is going to estimate the survivor average causal effect scaled by rho. And to the extent that we're just evaluating the sign here, the sign should be the same. Right, it may be harder to detect depending how small rho is, but it should be the same, okay? And so finally, when we look at the case of endogenous crime, so when we endogenize the suspect's decision whether to commit crime or not, we're going to think about how they weigh the benefits versus the increased probability of detection if reporting increases. And so we're going to characterize the subgame perfect Nash equilibrium here. As before, because we're missing this entire branch down here, the AT is going to be undefined due to selection into or out of crime. As in the previous cases, if we can condition on being on this branch, the survivor average causal effect will be the same. Again, z equals 1 here. But the difference in mean estimate is going to incorporate two different effects. It's going to incorporate the increase in reporting given that there is crime. So this is the survivor average causal effect. But it's also going to have this term that thinks about selection out of crime due to the anticipation of higher reporting and thus higher detection. Right, and you can get when you actually write this quantity out, which I haven't in the slides, is that this is going to be ambiguous in sign, right? So what we get out of a difference in means estimator here is not estimating either of these causal estimands, right, for the model, and it's also not giving us any test by which we can sort of evaluate predictions about what happens as the cost of reporting falls. Okay, and so taking stock of this example. Holding the research design constant, but changing the theory, we're assuming behind it, is going to tell us whether a given estimand, we talked about the ATE on reporting, is identified or not, right? So this is not a data problem. The data looks the same regardless of sort of what model that I'm assuming. And then also it has important implications for the interpretation of the treatment versus control comparison. Okay, this is much sort of better known, but I think it's important that we think about what sort of that difference in means is getting us and what we can learn from it. Okay, and so I think the broader question that we want to get to here is to what extent the results are general. Okay, and so in this case, I want to think about characterizing properties of the underlying theory and what that means for identification of a much broader set of models and research designs. Okay. And so I'm going to think, and I want to define this idea of strategy set symmetry. And so for any history H, so in sort of game tree, you can think of that as a node. Model is going to be strategy set symmetric if the subsequent actor, so the next actor, has an equivalent strategy set regardless of the strategy selected at history H. Up until the terminal node, which is the end of the modeled game in which there's no subsequent player. And so it's sort of the easiest, most simple sort of way to visualize this, and this is these are sort of the easiest variants of these models, but there's sort of infinite varieties, right? Is that we have here player one is going to choose A or not A. In the asymmetric variant, player two only acts if player one chooses strategy A, right? There's no action for player two down here. Whereas in the symmetric case, player one is going to play A or not A as before, and player two has sort of identical strategies available regardless of what player one does. Okay, so this is sort of the visualization that we're going to work through. And so there's a proposition, and we're going to work through it visually, but the idea is that in an experiment in which standard identification assumptions hold, if a theory of post-treatment behavior is not strategy set symmetric, so if we're in this asymmetric world that was on the left-hand side of your screen, there must exist at least one post-treatment behavioral outcome for which the ATE is identified. But then there also must exist at least one post-treatment behavioral outcome for which the ATE is not identified, okay? And if we're in sort of this symmetric world, what this says is that at least for the modeled outcomes, so the outcomes modeled by the theory, the ATE should be identified. I think that one really critical piece here is that what this is saying is that identification is a property of the design and the outcome, not simply of the design, okay? So we're going to go work through a graphical intuition. So the first part of this suggests that the ATE of let's call this potential outcome of sort of the action selected here as A of Z. This is going to be identified in both cases, right? I can always, so long as I can measure what's happening at this node, I can look at sort of the average treatment effect of whatever Z is, whatever that's changing on the frequency with which A is selected, okay? However, the ATE of B on Z, on the left-hand side, this is not gonna be identified because the second player's action here is undefined, or it's not available. The strategy set is unavailable, and so the potential outcome is undefined. Whereas on the right, it is defined. So we can look at for example, we could evaluate the difference in frequency across these two branches and what player two is doing. Okay. That is not to say that this is not challenging interpretation, right? So as in the past case, there may be a direct effect of whatever treatment is doing, right? Whatever parameter change we have due to treatment may have a direct effect here. It also may have an indirect effect via what player one is doing. But I think this is better known. If we want to think about what a DAG looks like, I've sort of used this notation, which is used sometimes for missing data. I'm sort of moving it towards this. So this sort of DAG. So we can think about this looking the same, except B of Z is undefined for some levels of A of Z. And so regardless of sort of what the S demand is, it becomes very difficult to identify a treatment effect of Z on B without changing what that treatment effect is, okay? And so there's a couple of implications that I think bear working through. And so we have this idea in sort of this identification-driven research tradition that less sort of empirical assumptions are good. And that may well be the case, but I think when we think about theory, I don't think that we can make the case that the lack of a theory, so no theory, is the same thing as agnosticism. And so sort of one thing that comes from the proposition is that if you have a research design and you're claiming to identify the ATE on sort of a set of sequential or possibly sequential outcomes, and you claim that this is identified, it implies that you believe that the model is strategy set symmetric, at least through the measured outcomes, right? And so this is sort of a strong assumption about the world that we're making via these claims and not specifying a theory. And then I think one thing that's worth note is thinking about like how much of a theory we need. And so the identification results, so the proposition is going to just hinge on sort of the sequence of actions and players and the strategy sets, right? I've assumed nothing about the utilities or the equilibrium concept. in sort of this identification result. And so this is sort of a very, very minimal conception of like what a theory is. Though it's important to note that the interpretation of results is going to be greatly assisted, if not rely on the equilibrium or the concept of optimal behavior, depending on what type of model you're working with. And then I think one thing that's worth thinking about is I've been talking about behavioral outcomes throughout this talk. And so if we just think about beliefs as outcomes, so many dynamic models assume sort of incomplete information. It's much harder to conceive of beliefs as undefined. So it may be the case that in equilibrium, beliefs are ruled out or are fully revealed at some, or information is fully revealed. But it's harder to think of sort of a belief, not being available at a certain history in the game. And so I see this as more of a concern for interpretation, certainly not as much for identification. So if we want to think about attitudinal outcomes in this way. Okay, so I want to conclude with a number of recommendations for research design. I'm going to start with experiments because in some sense, the researcher has the most control on what's going on in an experiment. And so if we're in this world in which sort of my model of the world, what's happening looks like this. And so this is the most basic idea of sort of asymmetric strategy sets here. We could do a number of things. First, given that it's hard to identify and then also estimate what's going on given the lack of a player two's choice action in this branch. Right, so we could just stop analysis when histories are no longer strategy set symmetric, right? So we could just analyze this outcome or whatever measures there are of this A versus not A decision, right? That's not to say that we can't think about implications of the model for B or not B, right? It may be the case that we can measure things and look at how behavior in this first choice corresponds to like what we might predict. But in terms of measuring a behavioral outcome, we would stop here. A second thing we could do, and there's a number of sort of multi-stage randomization or multi-level randomization experiments, is to randomize twice. We could randomize something here, and we could also then, among players that get to this stage, randomize it or something here. And so this is, I think, creative. It's in some cases really hard to do. And I think one concern here is that there's no guarantee that whatever sort of partial equilibrium effects that I'm estimating here and here tell us anything about how these, what a general equilibrium effect will look like in the world. But that is an option depending on sort of what the setting of the experiment is. Another thing we could do is we could sort of flatten or redefine outcomes. We could think about categories. So Y being sort of we end up here, we end up here, or we end up here. So I think that this is sometimes promising when we have a single decision maker. So a single bureaucrat, for example, chooses not to respond to an email or responds in some way or another. And we can think about this as categorical. It makes it in sort of a strategic setting. This can become more difficult. Particularly if we care about the actual behavior of individual actors as opposed to some type of equilibrium outcome. So I think that there's a lot of interpretation challenges that this brings up, but it is possible that this can help us move around some of the problems of identification identified here. Okay. And then I think moving beyond experiments. So I think this is fully general. It's in non-experimental identification-driven research. I think that this is probably as big or more challenging than it is in sort of the experimental context. And that's because we, in general, observe less of the causal process. And particularly when we look at things that happened historically or things that have already happened, we have less ability to sort of move into the sort of parts of the research design and sort of gather information in the way that we would want to. And what this means, I think, is that it's going to increase reliance on the assumptions about the extensive form. We also often, particularly when these are historical, we have much longer post-treatment history. So when we think about what sort of behavior looks like moving forward, things become much more challenging, both in terms of modeling, understanding what's happening, and then understanding what it means for inference. That said, the recommendations from experiments generally travel. They're just more demanding. So this idea of stopping where sort of symmetry breaks down, I think is probably the easiest to do. Flattening outcomes, particularly when you have long histories, becomes like very, very complicated for interpretation. And then it's also, I think, even more challenging to find ancillary as if random variation. So it's hard enough to find sort of the first variation. And so trying to find sort of ancillary variation and then thinking about how those two things come together is quite difficult. And I think that there's also a lot for sort of ideas in this for other empirical research, whether it's focused on identifying causal effects or just describing the world. I think it's like really important to understand where behavioral measures fall in a sequence of behavior and what that means for what we can infer about what people are doing. So I think that this is, in some sense, very general, regardless of the focus on identification, which is what the results are on or not. And so in terms of conclusions, I think that we need to think much more carefully about what the sequence of behavioral outcomes looks like sort of across the board. And what I'm trying to argue here is that in this context, identification of a causal estimand is going to be a property of a design and an outcome. It's not just a design. And the reason that we need theory, we may like theory for many reasons, but one reason that we need it for identification is that it's going to guide us to the set of identified estimands. Though one problem that sort of emerges from this is what if a theory is wrong, which most theories are wrong. And so on one hand, yes, it can lead to mistaken inferences or non-inferences. So it may sort of make us more confident that some estimate is identified or sort of make us stop analysis before it might be productive to do so. But I think that we can also think this is perhaps not the most demanding definition of what a theory is. So the conception of theory here, as we discussed, is sort of the sequence and the strategies available. And then finally, sort of one way to like think about this is that it's not clear to me that there's like an alternative. So the absence of theory, as we showed, at least alongside claims of identification in this set of sort of research designs, is not equivalent to having no theory. It's saying something sort of non-explicit but kind of restrictive about what's happening. So I think that there's a lot of work to be done here in terms of thinking about how theory and sort of identification integrate and what we can learn from integrating the two and sort of the limits to knowledge production. And so I think in some sense, this is open to further research. And then in terms of a theory versus identification debate, which has sort of been around in the discipline for at least like the last 6 years, is in some sense, if people are right that there is some competition between this, which I think is debatable, if the quest for identification leads us to underspecify a theory, this can be sort of self-defeating, right? It can actually limit what we're able, sort of the causal estimates that we're able to identify in the world, or the sort of validity of the inferences we're making. And I think one concern that comes from this paper is sort of if we think that sort of a focus on identification leads us to some topics and not others, which is, I think, has been stated pretty often by John Huber and others in the discipline, that sort of what the hardest part here are some of the things that are perhaps most interesting. So things where we just have a set of static sort of attitudinal outcomes are perhaps not challenging in this. And so like one concern about sort of how this is interpreted is that this directs us to study questions that are less interesting or even a more limited set of questions. And that's not the focus here. The focus here is just how can we make this type of research better and what can we learn from theory. And so I'm grateful for the opportunity to present and look forward to your questions.
Oh. Okay. Thank you, Tara, for that presentation. At this point, Tara Slough is available to take questions from the audience. You can ask a question using the Zoom Q&A button that appears at the bottom of your webinar window. And while we're waiting for questions to come in from the audience, I'll ask a couple of questions of my own. So, in 1979, J.J. Heckman writes this paper essentially arguing that there's a thing called selection bias, and you should account for that when you're estimating the effect of some treatment. And here's a model that does that. So, how is what you are arguing different than what he was arguing in 1979?
So I think that the context is different. So I mean, I think that you can see this as consistent with the Heckman argument. And I mean, I think that one alternative, right, to this problem is to go sort of much more structural, which is where some of that work has gone since. So we have the model, we know what the selection process looks like, and we can model it, and this can give us sort of different set of effects. I think that this is much more. I think this is much more sort of catered to where we are right now as a discipline, or thinking about what the merits of sort of research design for identification and sort of this idea of taking away assumptions as sort of a merit is. And so I want to think about this as being instructive for people that want to work within sort of a more sort of agnostic empirical tradition, and sort of what the limits to knowledge production are within that tradition. And I think that this is a paper that articulates, that maps sort of how one set of selection problems can be conceptualized within this framework, and how we can address it or not address it.
Well, but I was under the impression that you're sort of arguing that there's no such thing as agnosticism. So if people want to operate in the mode of being agnostic about theory, doesn't your argument just say you can't do that?
Yeah, so on the theory side, it does. So, I mean, I've sort of abstracted away from the sort of minimal set of assumptions that we typically make in sort of, let's say, experimental research. So, in experimental research, we typically make some assumption about excludability, exogeneity of treatment assignment, or ignorability, and then SUFA. So, I mean, sort of taking these assumptions, the idea is that we probably need more on sort of an applied theoretical level to actually be able to identify effects in some subset of contexts to which we're typically only invoking this set of assumptions.
So if that perspective of agnosticism is wrong, why isn't the argument just Heckman was right, and you really can't get away from some kind of structural assumptions? You can change what they are, but you can't get away from making at least some assumptions.
Yeah, I mean, I think that that's consistent with the argument. It's just a question of how much that needs to be mapped into what we're actually estimating, right? So, I mean, you could read this as saying, like, you have to make assumptions about the theory, and so, like, you might as well go fully structural. I think that there's limitations to sort of what we can do structurally in political science, and it's also not really where the discipline is at the moment. It may be moving there. And so this is the idea, is that sort of taking the empirical tools that we're using, this is sort of what theory would lead you to do. It may be that this is so suboptimal that we want to move to the sort of much sort of more involved framework in which theory is integrated into estimation at sort of a much like more stronger level.
So going back even further in time, there were a couple of philosophers, Doom and Quine, who stated basically a philosophical epistemological principle that you can never test a hypothesis in isolation, because there are always ancillary hypotheses that are necessary to support the validity of the test. So in other words, you can't. There's no such thing as sort of evaluating something independent of all the other things you have to think about in order to even construct or conceptualize the test. So, and that, I'm looking at Wikipedia right now. I can't find the date. I know it goes back at least to the early 20th century. So, how is what you're arguing the same or different from what they were saying, sort of in the 1940s?
Yeah, so I think that it sort of, our comfort with just taking a theory as given, I think varies. And I also think that when we think about what this looks like, the structure of the way that we would evaluate the assumptions of the theory that are coming in may be quite different from the way that we evaluate the implications of the theory. And so I think that one of the discomforts with sort of this idea that you have to put a theory on top of things is this, like, what if theory is wrong? Like, how can we actually validate this is sort of what's happening? I think that one thing that we need to do is that we need to think about a little bit more holistically what that type of testing would look like, because at least sort of in projects that I've done, like in the field, a lot of this sort of assumption testing is qualitative, right? So this idea, for example, in the policing example of no false reporting. Um, so there's different ways you could evaluate that. But one way is to just talk to the people who sort of get these calls and see if that's valid or not. And so I think that one thing that we need to do, that it's worth testing many things at the same time, is to think about what the different strategies to test sort of the assumptions going into it versus the implications of the argument are.
So when I was in graduate school, from between 2003 and 2008, and slightly before then, there was a big push supported by the National Science Foundation to evaluate the empirical implication of theoretical models, right? And they funded an institute and all this stuff, and there were lots of APRSR publications and quite a few PA publications. And at this point, as one of the people who is kind of involved in that, I think it's fair to say that that movement did not have the influence on the discipline that its founders were hoping for. And in fact, we seem to kind of have swung in the other direction, in the sense that now quite a few people are arguing for some sort of agnosticism or pure experimental or some other CI strategy as the way of evaluating what's going on in politics. So my question is, if this agenda has failed before, and not that long ago, right? Pretty recently, within the span of my career, and I'm not that old yet. Why are things going to be different this time?
I don't know that they will be. I mean,
Okay, well that's the IMC. Thanks for coming.
no, I mean, so I mean, PITM is still running. I think that there's still good work coming out of that tradition. It just may not have sort of gained sort of the, like, as many people working within that tradition as maybe there could be. I think in one way this is in some sense a way to like a olive branch, I don't know if that is, to a community that sort of relies really heavily on agnosticism, and sort of thinking about like how this is actually really critical, even if we're really reticent to make assumptions. And so that's where I see this work as sort of being framed within or being directed toward the community of sort of empiricists in which I was largely trained in graduate school since 2013ish. And so in some sense, this is sort of a means of outreach and thinking about how that sort of tradition can be brought into something closer to an
idea. So I was thinking about your example with crime, and there's a similar example with vote by mail. So the question, a lot of people thought for a long time that if you made vote by mail available or even mandatory, then turnout rates would go up. And they don't, not very much, maybe a little bit, but certainly not dramatically. And it's possible that part of the reason why, like you said, is there's some sort of endogenous adjustment of strategies, right? So, for example, you don't drive people to the polls if there are no polls, and so that activity stops happening, but it's compensated for because the vote by mail ballots are cheaper and easier to fill out for someone who's homebound, let's say. But it's still the case. The sort of the ultimate conclusion is still that vote by mail doesn't boost voter turnout. So why do I care about sort of the internal workings of exactly why? The hypothesis was if the cost of voting go down, then voting rates will go up, and that didn't happen, right? That just didn't work out. So why is it that I should care that if I randomly assign vote by mail to certain counties or certain states, that I don't see an effect, and that's what I should expect.
Well, it seems to me that this is sort of a question about sort of whether I care about sort of some theoretical idea about cost of voting or cost being a deterrent to voting, or if it's just sort of a policy implication or just sort of a policy impact, right? So if I just want to do an impact evaluation on this, the thing that I probably care about is sort of how do rates of turnout change because of vote by mail. I may not care that much about what drives it. And sort of I just want to sort of pick something that will maximize turnout. I think if the question we're trying to evaluate is the cost of voting something that deters people from voting, that we have to understand what's going on sort of under the hood. And I think the other thing that we should also be thinking about is sort of, even if all I care about is sort of the policy question, right? So can I just get more people to vote by doing this regardless of why? If we're concerned about external validity or whether this travels, right, there's different approaches to thinking about what the problem is. One idea is just to do it a bunch of times. Another thing is, okay, so we can think about why this effect happens, and under sort of similar, like in similar or different contexts, would we expect a similar outcome or not? And it's not clear that we can do the second part of it without sort of some sort of underlying idea of what the mechanisms are.
So I want to ask one last question, and then I think we're going to be out of time. So the reason why the credibility revolution, as they label it, I guess they self-label it in economics, came about because people started to get very worried about the apparent, I don't know if you call it error or irrelevancy of estimates that were coming out of observational models, right? They essentially were worried that these estimates were fanciful. And if we're going to go back to something that looks more, at least somewhat more, like that old way of working, how are we going to prevent ourselves from falling into the trap of getting back to sort of highly model dependent, fanciful results that don't travel?
Yeah. So I don't think that that's what I'm advocating here. So all the sort of, to the extent that this paper is anything about estimation, it's not asking people to not sort of estimate in sort of ways consistent with the credibility revolution, so to speak, or the identification revolution. It's asking people to sort of not make fanciful statements based about causality based on sort of causal processes that are not specified, right? So we could think about an error being that we call some effect causal when it's not, because the comparison is invalid due to what stuff that's happening after treatment assignment. So I think it's like very consistent with sort of ideas about like sort of the credibility of findings that have been brought by this revolution. It's just saying like, hold on, we can't drop sort of everything on sort of an applied theory level and still purport to be identifying all just effects in general.
Well, that's all the time we have for this week. So I'd like to thank Tara Slough for being our presenter. I want to remind everyone that her presentation will be posted to our website shortly after this broadcast if you'd like to share the presentation or watch it again later. I'd also like to invite you to join us on Friday, November 15th next week, when we will host Amelia Hoover Green from Drexel University for a talk entitled Reconsidering Civil War Onset, Battle Death Mismeasurement, and Causal Inference. You can see our website, www.methods-colloquium.com, to get more information about this talk. Tara, thanks for being here this week.
Yep, thanks for having me.
See you next time.